Hello friend, today we talk about the topic Theodolite height of an object with accesbile base. So first we talk about what is theodolite and what is used in the surveying. So we parts about the major parts of the theodolite and functions also. First we take the telescope. This is an internal focusing telescope for viewing an object. This is also used this is also used for the view object and what height and clear and focus an object. Second is leveling head. 3-foot screws between parallel plates with arrangement to fix to it required and place a plumb bob. Support the instrument. And third is horizontal plate. This is a circular plate which fix on the trapeze. We check the after fixing the trapeze. First we check circular circular plate is are fixed or not by put on the some pen or and other things. Circular plate and solid conical spindle with graduation at its edges from 0 to 60 degree axis to spindle from the inner axis. It is rotate from 0 to 360 degree. Next part is vernier plate. This is also part of a theodolite. Vernier plate, a circular plate supported on a hollow conical part. Vernier scales on the diametrically opposite edges. The center line of the hollow cone from the outer axis. Fifth part is plate wire. It is split level mounted on the casting of the plates. One supported adjustable split level which is used for the leveling. The instrument is proper level or not. If the bubbles are come in between the split level, that it means the instrument is fixed in proper way. Next is clamps and tangent screw. These are types of screw which are fixed in the theodolite. Two clamps screws and associated the tangent screws control the motion of the plates. And next is circular main circle graduated to circular vernier. Main circle graduated to degree. Each degree divided into 3 parts. This is part clockwise to 0 to 360 degree. 2 verniers and we have 60 division taking 59 degree 20 divisions. This is a circular vernier which are used for the checking the checking degree which is given in degree and minute and second also. These are fixed in the upper part of the theodolite. Next is clamp and tangent screw. This is next is clamp and tangent screws. Major parts of the and the next part is frames. These are two frames which supported the vertical circle and the telescope. The line joining the support center each terminal axis or horizontal axis. Next is vertical circle. Vertical circle consists of a circle centered on a terminal axis. Graduated from 0 to 19 in quadrant from 2 vernier fixed to a T-frame. Next part is quadrantal system 0 to 90 degree. Vernier circle scale is in a horizontal circle when the telescope is horizontal and instrument is level. The vertical circle has 0 for leading the vertical angles. The leveling is done using the attitude bubble as more in the sensitive. This is the attitude bubble means the bubble in the split level which is for the leveling. And next is altitude bubble. Altitude bubble is a very sensitive bubble fixed in the T frame. This is the upper part of this is talk about the upper part of the split level which are fixed in the upper theodolite. This is center for measuring vertical. It is for the measuring the angles. The vertical clamps and tangent screw. The vertical circle has a clamp and tangent screw. The T-frame has clipping screw for tightening the frame for adjustment. Next is measure parts and function of the magnifying glass. Magnifying glass are mainly used in the telescope, which are used for the focusing the object and look the object to very far away from the our theodolite. It is a type of lens which is used in the telescope. Both horizontal and vertical can be easily read using magnifying glasses. Provided to at the ends of diametrically arm, and magnifier are also used in to take the reading of vernier caliper also. Compass it is a very useful to measure the direction and the theodolite is center in center or not. A tripod is a instrument which is a type of stand where the theodolite is fixed. The most important things about tripod is first we fix the in proper way tripod because if the tripod is not fixed, the reading is incorrect for setting theodolite over station. Plumb bob it is for measuring the centering the measure the center with the measure the center. This is theodolite image of theodolite. This is telescope and these are the lenses, and where the this is the position where the final caliper are fixed. Or this is the vertical. We check the vertical angles, and here with the horizontal angles. This is the uh, magnifying glass telescope, and there are here we fix two screws screw also, and these are the frame where the these are the circular plate we just talked about. These are the main plate where the tripod are. Maybe there are three where the tripod are stand. Or we talk about the horizontal angle about the theodolite who measure the horizontal angle. Center level focus eyepiece to sight the object clearly and use forcing knob. Lower clamp and tangent screw are for circle plate, and upper clamp and tangent screw are for vernier plate. Both the clamps never uh, loose together. Lower clamp loose and upper clamp tight. Both plates move together and no change in the reading. Lower clamp tight and upper clamp loose. Vernier plate moves and reading changes. Read both verniers record readings and to set zero, loosen upper plate, bring the reading very near to zero. Clamps and adjust upper tangent screw to get zero. Exactly. To tight with the zero readings, release the lower clamps, rotate the instrument, sight the object closely. Tighten the lower clamps and adjust with the lower tangent screw for exact bisection. First we set zero in the horizontal plate, release the lower clamp, bisect P clamps and adjust lower tangent screw for exact bisection. Release upper clamp, rotate and bisect Q clamp and exactly bisect with the upper tangent screw. Read both verniers and record the angle. For more precise work, set a different angle to bisect P and read from different parts of the plate. Repetition method. This is a type of angle method. Set the instrument for left face readings. Set 0 bisect, and to measure the angle POQ, read both verniers and record. this is the talk about the how to measure the angles and the theodolite and next this is the this is the horizontal angle. We talk about P O Q, and this is the horizontal line from the theodolite. This is the this shows the tripod where we fix the theodolite, and we may see the object P object, that's the angle is 12 degree 32 minute 40 second. We see the Q object, that's angle is 8 degree 46 minute 20 second. And now from the below the horizontal line we see the object, that's angle is 6 degree 52 minute 40 second. Now we take the introduction. Definition: trigonometric leveling is the process of determining the difference of the elevation of a station from observed vertical angles and known distance. We talk about the steps. The vertical angle are measured by means of theodolite. It said that if we measure the vertical angles, we by uses of theodolite, we first focus the object. First we focus set at 0 and first focus of the object by using of telescope. The horizontal distance by instrument, we talk about the set data point, the distance between the object and the tripod, between capital D distance. Relative height and calculated using trigonometric function. This is about using relative heights and calculated trigonometric function. If the distance between instrument station and object is small, correction for the earth curvature refractive is not required. Correction of the earth curvature refraction is not required. This is the image we talked about the previous slide. This is the our tripod where we focus the object. This is object 1, x1, x2 height, and these are the leveling lines, and these are the leveling lines. This is the actual ground level. This is where where this is the tripod, and where we fix the theodolite. We focus the object x1, and uh, this is the horizontal line where we measure the angle alpha. This is a type of method, direct method. Uh, when the observation is made from the one station is called as direct method. It is also known as a single observation. Reciprocal method, this is a type of method, reciprocal method. When the observation are made from the both station, then it is called a reciprocal method. It is preferred rather than the direct method because uncertain refraction are unlimited. Reciprocal method, when methods, these are types of method. Talk about elevation at a point by theodolite. Is a type of measuring angles and distance by using the methods of determination. Method of determination of the elevation of a point by theodolite. This is the our case. Base of an object with accesbile. Base of the object is inaccessible. Instrument station in the vertical plane as the elevated object. Third case is base of an object is inaccessible and instrument station is not the same vertical plane as the elevated object. So we move our topic, base of an object, accessible base. This is our diagram, and this is our where we fix. This is our tripod, which height of h1, where we fix the tripod, and this is the theodolite, and the distance between the object and the tripod is capital D, and where the height of the object is from the tripod is small h. This is our benchmark of the this is our bench R, where the height of from the theodolite is take as BS, and this is the A dash, where is the some symbol. A is equal to instrument station, A is instrument station, B is the point to be observed, and H is the elevation B from the instrument axis. This is talked about this H, elevation B from the instrument's axis. D, horizontal distance between A and the base of an object. This is the distance, horizontal distance between object and this base. Small h1 height of instrument. Small h1 means height of instrument. This is the height of instrument. Mainly talk about the tripod. This is the instrument. BS. BS means height of reading of a staff kept on BM. This reading where the take the reading of which are kept on the benchmark, which the height is BS. Alpha angle of elevation. This is alpha angle of elevation, which measure angle BAC. Where you calculate the accesbile height by using some formula, where the RL of B means RL of B equal to RL of BM plus BS plus H. Reducing level of B equal to reducing level of BM plus BS plus H equal to again you write that reducing level of BM plus BS plus D10 alpha. D10 alpha equal to by D10 alpha by using trigonometric calculation, because 10 alpha equal to 10 alpha equal to H upon D. Where you calculate H, then it becomes 10 alpha into D, where this is the value of H, D into 10 alpha. Let's talk about the long distance. If the distance is large, then add CC and CR. This is the long distance. If the distance between the base of object and the instrument, if the given very large, then we use this formula, or reducing level of B equal to reducing level of benchmark plus BS plus D10 alpha plus 0.0673 D square. D, where D square means this is the distance. This is the talk about the base of an inaccessible instrument station. The vertical plane is the elevated object. There were two cases: instrument axis at the same level and instrument axis of at different level. Height of an instrument axis never been to object is lower. Height of the instrument axis to object is higher. If we measure, there is two tripod which fixed on the but there are two tripod which are fixed on theodolite with B dash A dash, using this type of formulas. This is the another formula: instrument axis at different level, height of an instrument and object is lower.